Hi there, and welcome to today's class. We're looking at the study of Kirchhoff's law in physics. Let's look at the study of Kirchhoff's law in physics. So we'll state the law that governs Kirchhoff's law, and also we'll look at the two several branches of Kirchhoff's law. And aside that, we'll look at some important technique to note while solving problem under Kirchhoff's law. So let's look at Kirchhoff's law. Kirchhoff's law is used to reduce circuits that are too complicated to be reduced using series parallel method based on an Ohm's law. That's how you define Kirchhoff's law. And it was discovered or perhaps invented by a German physicist called Gustav Robert Kirchhoff. That's Gustav um, Robert Kirchhoff, right? The K here means Kirchhoff, right? So it was invented by a German physicist called Gustav Robert Kirchhoff. That's the person that invented the idea behind Kirchhoff's law. So let's proceed with the laws involving Kirchhoff's, right? So there are two laws. So it's important to know that there are two types of Kirchhoff's law. So the types of Kirchhoff's law, let's look at types of Kirchhoff's law. So we said there are two types of Kirchhoff's law. The first one there is called the Kirchhoff current law. So I have Kirchhoff's current law. So in abbreviation sense, it's called the KCL. This means Kirchhoff current law. Next up, number two there is called the Kirchhoff voltage law. That's KVL. So I have Kirchhoff's voltage law. That's in bracket, that's KVL as abbreviated. So KCL means Kirchhoff's current law. KVL means see that sound. So all right, I said there are two types of Kirchhoff's law. The first one is called the Kirchhoff current law. Next up, I have the Kirchhoff voltage law. Let's look at this law one after the other, and take their mathematical expression.
Alright guys, you can now join my channel membership to have access to exclusive videos of mine which most people will not have access to. To get this link to this membership program, as you can see the left hand side of the screen, you can see the YX/JAM classes. You can go there. It of course 1000 naira, or you go for the 100 level student to have access to both, right? So once you join the channel membership for other level students, you will have access to both the WAEC and the JAM classes with the other level itself. So do well to join this membership to support our online academic session. See you guys sooner.
Number one there, let's go to number one. Number one there, we have the Kirchhoff's current then law. That's KCL. So let's discuss Kirchhoff's current law. This states that, or perhaps Kirchhoff's current law or Kirchhoff's first law of current states that at any junction point, the sum of all currents entering the junction must be equal to the sum of current leaving the junction. So Kirchhoff's current law says that the sum of current entering into the junction must be equal to the sum of current flowing out or leaving the junction. Or you can state Kirchhoff's current law as the sum of all current entering a nodule in an electric circuit must be equal to the sum of all current leaving the nodule. So that's so the difference between the two law I gave you now was the first one there I use junction, the other one there I use nodule, right? So either of the two they are still the same thing. So for Kirchhoff's current law, the idea is easy. Here's a concept. The sum of current that's entering into this junction or the circuit must be equal to the sum of current flowing out or leaving the circuit. That's how I state Kirchhoff's current law. Mathematically, we said Kirchhoff's current law says that the sum of current entering into the junction must be equal to sum of current leaving the junction. It's easy as I'm saying that the summation of V equal to 0. That is, the sum of current is I. So the sum, this one means sum. The sum of current entering into the junction must be equal to the sum of current leaving the junction. So I have in and out. So this is what Kirchhoff's current law is saying, that the sum of current entering into the junction or nodule must be equal to the sum of current leaving the junction, or use the idea of nodule. So this is how you state Kirchhoff's current law. To explain this better, I'll draw an image here, and from the image, we'll try to apply the idea of Kirchhoff's current law. So let's say I have an image of this nature. Let's say I have image of this nature, and I have my point A here. Call this point A, or perhaps junction A if I want to, or you call it nodule A. So alright. So I have this line this way. Now I have my first current. Call this man I1. That is my first current is facing this direction. Next up, I have another current this way. Call this man I3, my third current, and I'll call another direction. Let's say the last one is moving this way, another current flowing this way. Let's call it I2. Please observe in this circuit or what have you, observe that I1 is coming in. Observe that I3 is flowing out and I2 is flowing out. So here's the idea, please. I1 is coming in. That match the idea of summation I in. So I1 is corresponded to summation I in. Why I3 and I2 are leaving the circuit? That follows the idea of what? Summation I out. So I'm saying this now. If I'm to apply Kirchhoff's current law, I'm saying that the sum of current entering. Please, how many current is entering the circuit here? Just one, and that's what I1 is flowing in. So from there, I'll have that I1 is equal to I1 is flowing in must be equal to the sum of current flowing out the circuit. So I3 and I2 are leaving the circuit. So because what there? I2 plus I3. This is simply the basic idea of Kirchhoff's current law. That the sum of current entering into the circuit must be equal to the sum of current leaving out or leaving the circuit. So this is like the basic knowledge behind Kirchhoff's current law. We'll look at the second law called Kirchhoff's voltage law.
Guys, I just launched some courses on my website. These courses include physics tutorial for year 1 student, YX/JAM student, YX/JAM classes for JAM student, and also I have the organic chemistry for beginners. So these courses, you can get these courses on my website, as you can see displayed at the right hand side of the screen.
So let's look at number two. Number two, that is called Kirchhoff's. Let's do Kirchhoff's voltage law. That's KVL per se. This one is called KCL. Why? The initial. This is K, this is C, and this is L. That's KCL. This man is called KVL. Why? The initials. This is K, this is V, and this is L. So this man is called KVL. Please don't forget, we said that for Kirchhoff's current law, sum of current flowing in, please in first before out. In should come first before out, not out before in, please. So sum of current flowing in must be equal to the one coming out. That's, by the way, let's state Kirchhoff's voltage law. This states that hold on please, before I proceed is to state this one here. I can call this man Kirchhoff's current law or junction law or junction rule if I want to. So bear in mind, I can still call this man junction rule or junction law. So also bear in mind that Kirchhoff's voltage law can also be called loop rule, right? Loop. We'll look at loop and mesh in our next class. So bear in mind that Kirchhoff's voltage law is also called loop rule. That's, by the way. So put a place. This under this place. Under this, it says this is also called loop rule. It states that the algebra sum of the change in potential difference around any closed path of the current must be equal to 0. This states that the algebra sum of the charges in potential difference around any closed path of the current must be equal to 0. That's how it states Kirchhoff's voltage law. At this point, please note one important thing, please. Note. All right. After setting the law, note one important thing, please. Note, please. The potential difference consists of EMF. This one, EMF. What is EMF? EMF means electromotive force. That's EMF. So I'm saying that the potential difference consists of EMF, that's electromotive force, and IR drop across resistor. The loop rule may be written in the equation below. The loop rule may be written in the equation below. I have this place. E plus IR equal to 0. All right. So this one important thing to note that the sum of E plus IR should be equal to 0. So this is how you state Kirchhoff's current law and Kirchhoff's voltage law. So we have looked at these two laws here. Now, here's the idea. If I see a question under Kirchhoff's current law or perhaps Kirchhoff's law, if I have a question under Kirchhoff's law, how do you solve it? What are the things to note? Because you can apply just law in solving. There's some steps you need to know. There's some things to be familiar with. So now at this junction now, we're looking at what and what to put in place when you see a.
I just launched a book called The Shortcut to Academic Success. In this book, I share a lot of experience on how I evaluated during my time in school. This method really helped me a lot. If you're interested in getting this book, simply chat me up through my WhatsApp number that is shown in the screen.
Kirchhoff's law question. That's case 1. Case 2, we're looking at some 4 to 3 important things to note. So when you see this important thing in the question, just apply them. So without a 4 or 3 important thing there, you can't get how to solve problems involved in Kirchhoff's law. So let's look at some basic terms that you need to be familiar with when it comes to solving problem under Kirchhoff's law. Welcome back. So let's dive into the several important key concepts to note why solving problem under Kirchhoff's law. So note the following, please. Number one. So that's number one. Number one. So the first important thing to note when you see a problem under Kirchhoff's law is that, put on please, when the current move from high to low potential, when the current move from high to low potential, comma, the voltage when the current moves from high to low potential, the voltage is taken as negative. So that's the first case there. So when current is moving from a high to a low potential, you take voltage as what? As negative. What do I mean? Let's say I have this way. Of course, this is a cell or battery. So this man is moving from a high, which is positive, to a low potential. We say that when a current is moving from high to low, ensure that voltage is what? Is negative. Let's assume that my voltage is, let's say I have 3 volts here. It means that the summation of V will be what? Negative 3. Negative 3 volts. Why is it negative 3 volts? Because we said when current is moving from a high to low potential, take V, or perhaps take voltage as negative. And I said if I have 3 voltage here, it means that summation of V is equal to what there? Negative 3 volts. So bear in mind, that's the first case. When current is moving from a high to low, take V as negative, please. Number two, number two says when the current moves from a low to high potential, the voltage is taken as positive. Please, this implies to case 1. Case 1 says when current is going from high to lower, take V as negative. Case 2 says when current is going from a low to high, take V as what there? Positive. So if I have my voltage this way, I have this man, sorry, we said moving from lower. So I have a lower to what? A lower to higher potential difference this way. Let's say here is 3 volts. We are saying that summation of V will be equal to what there? 3 positive volts, 3 volts. So observe that if it's moving from a high to lower, I have negative volts. If it's moving from a lower to higher, I have a positive vote. So these are the first and second thing to note. Number 3, let's look at number 3. Number 3 says current flow from the positive to negative terminal in a resistor. Current flow from the positive to the negative terminal of a resistor. To explain this better, we know a resistor, right? A resistor is a device used for measuring the rate of current in a circuit, right? And from resistor, we look at Ohm's law, what have you. I've done the video to that. So I'll drop a link to that class in the description of this video to resistor. And that's, by the way, we know that we can represent resistor in 2 forms. It can be in this form or in this form. These 2 signifies resistor, so I can use any one I wish to use. So these 2 are symbolic representation of a resistor. That's, by the way. I'm saying that number 3 says that that in a resistor, current flows from what? Positive to what? Negative terminal, right? So that's the idea there. So let's say I have a resistor. In quotes, I'll draw 2 resistor. Let's say I have this one, this resistor here, Call it resistor A, part A, and I have another resistor this way. Call this one B. Are we good? Now, here's the idea. We said in a resistor, please listen. In a resistor which I've drawn, current flow from positive to what? Negative. Now, let's say I have a current flowing this way. Call it I. Let me call it I1. I have another current flowing this way. Let me call it I2 this way. For this resistor and this resistor, here is the idea. For a resistor, we said current flow from what? Positive first. So it means that here becomes positive, here becomes negative. Why? Because current is flowing this direction. And if it's flowing this direction, it means it will pass through plus before negative. That said positive first before negative. So I'm having it moving this way. It means that it will pass through plus before what there? Before minus. That's case 1. Case 2 says that, let's say I have current moving in opposite direction this way. So what will be plus, what will be minus? My plus will be here. Minus will be here. Why? Because my current is flowing this way. It's flowing this way means it's moving from positive towards negative terminal. So these are the concept behind the 3 ideas to note when it comes to solving problem involved in Kirchhoff's law. All right. I want to explain the idea behind number 3. Number 3 says that when the just like that, wherever your current is flowing through, the direction matters a lot. Moving this way means it's passing to positive to negative. This way means positive to what the negative. So ensure that when current is passing through the resistor, here's the idea. It's always moving from what? Positive to what? Negative terminal, please. That's like the idea. So on the number 3, please note this, please. Note, please. Note. Note this, please. Note. Hence, if the direction of the current given or assumed, hence, if the direction of the current given or assumed is the same as that of the current, comma, the voltage is negative. I said, if the direction of the current given or assumed is the same as that of the current, the voltage is what there is negative. What do I mean? Look up, please. So let's say I have this direction here, clockwise direction. This one too, I have a clockwise direction this way. Please observe that this assumed direction is following or is corresponding with the given direction of current. If they are the same, all right, I said if direction of the current assumed is corresponding with the given current, is corresponding with the direction of the given current, take V as negative, right? So observe that this assumed direction is following the pattern of the original current. So it means they are almost the same thing, they are alike. This direction, this one too follows the same direction, right? So I'm taking V as what there as negative. And here's the idea. From Ohm's law, we know that V is equal to IR. This man here, so this idea here was from Ohm's law that V equal to IR. So I'm saying this, please, that if the direction of the current given or assumed is following the direction of the given current, take V as negative. So it means that summation of V will be equal to what there? Negative IR. Now, observe that V equal to IR, as I showed you here. So the sum of voltage must be equal to what there? Now, here's the idea. This given direction, or let me call it assumed direction, if you observe very well, is following this given direction, right? So if they are the same, take V as negative. For this one here, Observe that the assumed direction is not following the original direction given here. They are moving in what? Opposite direction. This one is moving this way. This is moving this way. Opposite direction. Take V as positive in this case. So I'm seeing for this case too, yeah, for B, the summation of V is what? Positive what? I R. So I have this expression. These are like the two stuff to note when it comes to Kirchhoff's law. Please, in the next class, we'll look at how to solve past question for the last 10 years involved in Kirchhoff's law, and then we'll also look at the idea behind loop and mesh. What's a loop? What's mesh? We'll look at those concepts in our next class.
I just launched my website www.ghanabukari.com, as you can see in the screen. In this website, you can get close to 4 to 5 tutorial courses that are there. So we have different courses there. Also, the book I just launched also is in the website. You can visit our website and get the courses you want to watch. And also, the video you're watching recently, you can get more of these interesting videos in the website. So do well to visit the website and also register an account with my website. See you guys in the website, and make sure you buy a course from the website to support our journey of this academic platform. Thank you guys, and welcome to my channel.
If you found this class helpful, do it to like the video, share to your friends and classmates. Also subscribe to my channel. If you're interested in learning more, or perhaps if this video interests you, do well to visit my website at www.granabdo.com. I'll leave a link to my website in the description of this video. So go there and get the link. In the website, I printed some courses there. You can get the courses, science courses on website. So go there and get a course. And also, I just launched a book. Go to the website there. You see the book I launched. You can go there and purchase the book if you want. If you find this class helpful, do it to subscribe. And once again, you're welcome to Excellent Link Academy. We'll look at the idea of loop and mesh in our next video.